All right, hello again. Now we're going to talk about two very important concepts, risk matrix and hierarchy of controls. You're going to hear these a lot in this class of mine and in a lot of classes of mine. I think they're very important. So we've identified the hazards, next module, okay? Got all this bunch of hazards we found. Now we determine which hazards are the most serious risks, so we can look at those first. We got, let's say, 5 or 6 different hazards that are worth looking at. So now we're going, what are you going to do with them? So that's where the risk matrix and the hierarchy controls come in. There are many different risk matrices out there. Notice the plural of matrices, matrices, so you know that, so you don't look stupid. In process safety management, PSM, we used a 4x4 matrix, mainly because that's the one that the ammonia industry used, and so did our consultant during a process hazard analysis, and we'll discuss PSM later. I prefer the 5x5 one, which we're going to use in this course, and I'll make in other courses too. So let's look at it, and then we're going to talk about it. This is what it looks like here. I'm going to move my head here. All right. It shows incident outcomes, likelihood of occurrence. So you have two different things. You have the severity level over here, and you have the likelihood of occurrence over here. And you can see that 5 times 5 is 25. 4 times 3 is 12. All right, basic math. Now we have incident outcomes, and we're going to talk about each of those, each of this, or all this stuff in more detail. So we start at the left, the severity level. One thing I like about this particular risk matrix is that it lists 3 different categories of incident outcomes, because the hazard that you're looking at might not be to people. It might be to property. It might be to the environment, the hazard. Most likely it's going to be for the first one, to people. But that's what we're mostly concerned about in safety, but it happens. So you have the 3 health effects people, property damage, or environmental. There's the possible incident outcomes. There you go. Health effects, which is people, property damage, or environmental impact. They're all important. An event could have an impact on any one or more of these categories, but usually predominant outcome will be just one of them, usually. So, excuse me, here are the health effects or people. First aid or no injury or illness, which would be a lowest on 1, to first aid or nothing. Injury, illness, no lost days. Okay, that would be, it could be recordable. We're not talking about that here now. So but no lost days. Injury, illness with 1 or more days away from work. Now, when that start lose days of work, it's getting pretty serious. 4, permanent partial disability, hospitalization of 3 or more. 3 or more people, that is. Death or permanent disability. That's pretty serious, obviously. The next column is property damage, and your property damage can be light, moderate, significant, severe, catastrophic. Now, they don't give you dollar figures here, or that. This is kind of, a lot of these things are judgment calls. And if you're driving a car and you get a fender bender, that's pretty light, right? Maybe if you have to have a hood replaced, something like that, it might be considered moderate, So you'd have to look at this for what each individual occurrence, obviously, for each one of these, and make a judgment call. A lot of these are judgment calls. The third is environmental impact. Light, moderate but reversible, significant but still reversible, and then significant. No, that's really, really bad. Well, let's move over to the likelihood of occurrence reading across the top. The likelihood of something occurrence is very unlikely. Let's see, airplane falling on your head. Okay, could it happen? Heck yeah, it could happen, but very unlikely, right? Or just unlikely. You in a car wreck. It's probably unlikely, but it's not very unlikely. It's very it's unlikely, but possible you could be in a car accident. Of course, possible. Those are, it's a little, you have to use some judgment here on these. Very likely, they're likely, or very likely. So you can take it like, again, let's say you're walking out from work to the car. Under normal conditions, probably the chance you get hurt is very unlikely. But what about if there's ice on the street or ice on the sidewalk, parking lot, everything else? It's been an ice storm. You might get down here to possible, or maybe even likely, you're going to fall. So the same thing under different conditions could get different outcomes. Here you go again. Likelihood of occurrence, very unlikely, unlikely, possible, likely, and very likely. And anyway, so again, we just multiply these and we get the number over here. the number severity level is then multiplied by the likelihood of occurrence number to get the risk number. So that's the bottom, the number we're looking for. Across the bottom of the chart, the risk numbers are ranked 15 or greater, very high risk, 10 to 14, high risk, 5 to 8, moderate risk, 1 to 4, low risk. Color coding just to make it easier to read and interpret. So we use this risk number for several reasons. Get the idea of a severity of a particular hazard. Let's just say there's one hazard we're looking at. Okay, I want to talk about, well, you know, how serious is that? Well, let's take a look at the risk matrix and let's determine that. Or let's say we have 6 hazards we have to deal with. We can do it each one on rank them. Okay, we'll just see what the most serious ones are. We can rank them that way. That's a good way to do it. Another good way to do it is we can establish a risk number for the current system. Okay, this is the way we're doing this now. Let's go ahead and do this. Go through this exercise and give it a risk number. And then introduce controls, ascertain the revised risk number to get an idea how good the controls are. So let's say, you know, if it's a 20 and you put some controls in, you get it down to a 12. Well, you've made that safer and that about it, or less risky. So it's a good way to do that. Now we're going to talk about the hierarchy of controls. Now, notice the bar on the left. It says most effective at the top. Indicates the most effective to the least effective. It's time to color code it along with the colors of the hierarchy of controls. And this is the part you really need to keep it to memory. Elimination is number 1. And what does it do? Physically remove the hazard. Gets it completely out of there, right? That's the best way to do it. If you can do that, completely get it out of there, that's fine. Substitution, replace the hazard. Replace it with something less hazardous. Now you have to be sure it's left less hazardous. It can be you can replace it with for instance, some cases a fine granules of something, of a chemical, would be less hazardous if they were in a more of a solid form. So that's one way of doing it. The engineering controls isolate people from the hazard. This is huge in safety, because one of the biggest things that we see all the time in production manufacturing is guards. We isolate people from the hazard. We got a hazard here. We got something that cuts a piece of equipment or does some work on it, or punches or something like that, or chains and sprockets and all that stuff. So what do we do with it? We isolate people from the hazard. And we do that usually with guards. You can do it with light curtains, other ways of doing it. But the easiest, simplest way is guards, machine guards. Now, let's say we can't do that, or sometimes we do these in conjunction with the other things. Administrative controls, change the way people work. Now, that's hard to do sometimes, because now people change. So you have all new people coming in, so you might change the way the current staff works, but then next month there might be some different people in there. So that's one of the problems you have. But changing the way people work, it requires like work rules or something like that. So somebody has to write the work rules, somebody has to train people on them, and these people have to follow them, and somebody has to enforce that. So there's a lot of stuff that goes into administrative controls. So if you can use an engineering control, like just slap a guard on it, put a guard on it, so people can't probably get hurt on it. You can still remove a guard. I mean, let's face it can happen, and it does. But a guard is way better than an administrative control. Again, most effective to least effective. And let's say you've tried everything else and nothing else works. PPE, protect the worker with personal protective equipment. Sometimes you use PPE in conjunction with other things. One of the biggest things like PPE is noise. Sometimes you can't get rid of the noise. You just can't. So what do? You use hearing protection. So protect the worker with personal protective equipment, hard hats, safety glasses. Okay, you're out there. I'll just give an example. You're out there mowing your lawn. So what do you wear? Well, it's noisy, right? So you wear hearing protection. It's a danger to your eyes. So you wear eyeglasses, right? You should be anyhow. So we start at the top, elimination, again, physically remove the hazard. There are some others out there. Some will add warnings between engineering and administrative, but I consider a warning an administrative control. So you'll see some hierarchy of controls out there. Again, you'll see lots of them out there, just like you'll see risk matrices. But you have to pick one. This is the one that I picked, and I think it's the best one. So warnings I consider to be an administrative control. So again, start at the top, substitution, replace the hazard. obviously with something less hazardous. Elimination and substitution are usually much easier to implement if they are addressed in the planning stages of a project. Once a project is ongoing or systems in place and going, it's hard to eliminate or something or substitute something. Sometimes it can be done, but again, things vary. So, but they are much easier to implement if they're addressed early on. Again, once something is more of a going concern, it's much more difficult to either eliminate it or substitute for it. So again, elimination, physically remove the hazard, substitution, replace the hazard. The next three items are the ones will most likely be used in normal operations. Engineering controls isolate people from the hazard. Examples, machine guarding, interlocks, that type of thing. They're usually something physical that isolates people from the hazard, keeps you from doing it. Administrative controls, again, change the way people work. Training, policies, procedures, job rotation, warnings, signs. Job rotations, for instance, there's a good way of doing it. One thing at OK Foods, they had one inspection station in the kill plant where the birds came through, and one person had to be looking down in them all the time and inspecting it, and the other will stand up and do trimmings and stuff like that. Well, they worked in teams, so every 2 hours at break time, they'd switch jobs. And it was really well done because also the stations they were on were adjustable. So if you had a tall person and a short person, they could just with a switch adjust the height of those two. So it was a really, really good. Somebody had put that in long before I got there. A good way of doing that. Protect personal protective equipment. Protect the worker with PPE. Again, the last line of defense is PPE. Hard hats, safety shoes, safety glasses, fall protection, welding hoods and clothing, protective gloves, hearing protection. Again, there you go. Elimination, physically remove the hazard. Substitution, replace the hazard. Engineering controls, isolate people from the hazard. Administrative controls, change the way people work. PPE, protect the worker with personal protective equipment. Hierarchy controls pros and cons of some of them. The most effective in the hierarchy controls start at the top, elimination and substitution. These two are usually easiest to do in the planning stages again, and much more difficult to do in an ongoing operation. Of the bottom three, engineering controls are by far the best because they usually don't require the employee to do anything. They're just there. So in other words, when the operator shows up on the job and the machine's ready to go, it's running, its guards are in place and everything. So the operator or the employees that are running it, they don't have to do anything. Those guards are there. Now, is it possible they could take a guard off? Yeah, probably. Of course, they should be probably fired if they do, if they're not authorized to do so. But as a rule, the guards are going to be there. The engineering controls are going to be there. Administrative controls, again, they must be formulated. People must be trained in them and use them. And that's an ongoing, constant procedure. People change, we get new people in. So administrative controls are a must. You got to have something. You got to have training. So even if you have something like, you have lockouts, administrative control. Even though you're using a lock and something like that, but it's training. You got to train people to do it. And they have to do it, and you have to enforce it. So there's a lot to do in administrative controls. It's more people heavy. So PPE requires the user to do something, and they must be trained how to put it on, use it, take it off, clean it, care for it. Sometimes getting them to wear it's a problem. I can't tell you how many times I've seen people without hearing protection, so or eye protection. And we had a guy at Fort Smith at the wastewater plant who dropped a cylinder and broke his toe. And I looked into it a little bit. I found out, guess what? We bought him safety shoes, and they were at his house. He didn't wear them. He didn't want to wear them. He was wearing tennis shoes. So here he has PPE. He wasn't wearing them. So I told this boss he had to write him up. Well, he's a good guy. Says, he's a good guy. All right. Look, I'm not saying fire him, but write him up for not wearing his PPE that he had. That's a constant problem is getting people to wear PPE. In most manufacturing industries, there will be a mix of engineering controls, administrative controls, and PPE. Here's a scenario that could easily happen to you when you're in the safety department. Your company acquires a new piece of equipment, or a new company, or something new, or dramatically changes something, but something new happens. The discussion is started as to how to make it safer. You immediately take the lead on this conversation and rank the hazards using the risk matrix, and then apply the hierarchy of controls and steer this decision-making process in a sensible, intelligent manner. Now, you're probably going to have the other people that are involved in it work with you on it. By all means, get them involved in it. Let them know. It's not a secret. Let them know what you're doing and why you're doing it, and help you on it. And you can come up with something, and then once you come up with something and they've been involved in it with you, then it's going to be a lot easier to get it implemented. So these are two tools you'll most likely use often in your safety career: the risk matrix and hierarchy of controls. That's it.